Friends, this is Venkat. In this video I will be discussing some of the Java 8 features. So many features have been included as part of Java 8. So some of the important features are like Lambda expressions, functional interfaces, default and static methods in interfaces. So before 1.8 we cannot write concrete methods as part of interfaces. So from Java 1.8 we can have default concrete methods and as well as static methods as part of interfaces. And the next one is method reference, streams and date and time API. So out of which I will be concentrating on Lambda expressions, functional interfaces, method reference and streams. So the main objectives of Java 1.8 are it simplify the programmer's life by eliminating a lot of boilerplate code, and it enables functional programming benefits in Java. So we will see these benefits as part of our next slides. So and enables parallel processing in Java. So nowadays we are having multi-core processors, right? So in order to take advantage of this multi-core processing, so 1.8 has introduced this feature. So why lambdas? So Lambda expression facilitates a functional programming and it simplifies the development a lot. So and it eliminates a lot of boilerplate code. Okay, and we can assign a function as a value to a variable. So far we cannot assign a block of code to a variable. So by using functional programming benefits, we can assign a block of code to a variable and we can send this block of code as a value to as an argument to another method. Okay, and it enables support for parallel processing. So functional programming lets you write more readable code. So lambda expressions or functions are not belong to a class or object, they exist in isolation. Okay, and these functions are treated as values. So in mathematical world, lambda expression is like it will take some input and generates it will be like a function will take some input and it will generate some output. So the syntax is looks like this. So we can have the parameters as part of simple process, and this is the arrow mark, and then we have the body of the lambda expressions. We can have any number of statements as part of body. If we have only one statement, the curly braces are optional. So let us see how to write a lambda expression. So before writing our lambda expression, so we'll look at this sample example. So here I'm assigning this hello world string to a variable. Okay, this is called a inline value. Okay, so how about if I want to assign a block of code to a variable? This is not possible using object oriented programming language. Okay, so usually we write our method like this. In our regular day-to-day coding, we'll write our methods like this. From this code we'll derive the lambda expression. Okay, so lambda expression, as we discussed, lambda expressions exist in isolation, so they don't belong to any class or object. So having access specifier to a lambda expression is meaningless. So I'm just removing this one. So I'm treating this lambda expression, I'm assigning a block of code to a variable, so I can refer this block of code with using this variable. So I need not to have a name for this lambda expression. So I'm just removing this method name. So lambda expressions, so I left with only the return type. So in Java 1.8 the compiler is smart enough to find the return type, so I need not to have this return type also. Okay, so now I left with parenthesis and body of the method. Okay, so according to the lambda expression signature, I'm assigning a arrow mark here. Now it becomes your lambda expression. Okay, so if we have only one statement, one line of code in your lambda expression, so the curly braces are also optional. This is my lambda expression. Okay, so let us write another lambda expression. So this is add function. I'm assigning this block of code to this variable. So in this function, this lambda expression is taking two arguments a and b, and it returns the sum of these two numbers. Okay, so what is the type of this lambda expression? What is the type of this variable? For example, the type of this variable is string. Okay, so what is the type of this variable? Okay, in Java 1.8 they haven't introduced any type for to refer the lambda expressions, so we need to write our own functional interface like this. Okay, here, so if you look at this lambda expression, I'm assigned this function to a variable. This is of type add function. Add function is like a interface, okay, which is having only one method. This is called a functional interface. Functional interfaces are like our regular interfaces. So in our regular interface we can have more than one abstract methods, but in functional interface we must have only one abstract method. Okay, so let us see some examples, so you will understand more. Let us look at some examples of lambda expressions. So in this example I have two lambda expressions. So the first one is taking a string as an argument and just printing the length of the string. Okay, second one is taking a couple of arguments, integers, okay, and just returning the sum of the two numbers. Okay, I have two lambda expressions. Okay, before running this example, I'll just discuss about differences between lambda expressions and inner classes. Okay. Okay, so this is inner class implementation and this is the lambda expression. So lambda expression, it looks like like implementation of the anonymous inner class. Okay, here also I'm taking the string as an argument and just printing the values. First let me run the lambda expression so that you can easily understand the example. So let me run this one. So I'm running this example. So it printed sum is 3. So this is the sum of the two numbers is 3 and the length of the hello world is 13. Okay, so instead of lambda expression I'm just taking this inner class implementation. Let me comment out this one. Let me run this program. So this time also I'm getting the same output. So there is no difference as part of the if we consider the output, there is no difference between lambda expressions and the inner class implementation. So we can also write instead of lambda expressions I can also go with inner class implementation. What is the certain difference between these two? So if you see the differences between lambda expressions and inner classes, so in inner class we can extend concrete and abstract classes. So inner class can extend concrete and abstract classes, but in lambda expressions or functions we cannot extend any class or uh, and as well as abstract class. Okay, the second difference is, so we can extend interface having multiple abstract methods as part of inner classes. So if we consider the lambda expressions, we can extend an interface which is having only a one method, so that is nothing but a functional interface. Okay, and we can declare instance variables as part of inner classes, but we cannot declare any instance variables as part of functions. So okay, this keyword refers to inner class object. So for example, if we have any this keyword any anonymous inner class, thus this keyword refers to the inner class object. So whereas in functions this keywords refers to the outer class object. So we can instantiate anonymous inner classes, but we cannot instantiate lambda expressions. So these are some of the important differences between lambda expressions and inner classes. Okay, and okay, this lambda expression is of type lambda expression, and this lambda expression is of type add function. So I wrote two functional interfaces. Okay, the first one is this functional interface is having only one method, which is taking a string as an argument, and it returns nothing. Okay, so if you look at this lambda expression, this is taking one string as an argument and just printing the value of this string. So in the same way, in the second lambda expression, it is taking two arguments, integer a into a and into b, and I'm just returning the sum of these two numbers. So this lambda expression, this functional interface is also having only one method. For example, this functional interface method signature should satisfy the parameters which you are arguments which you are passing to a lambda expression. So for example, if we take another integer here, if we change the method signature, you will get a compile time error. So lambda expression's signature does not match the signature of the functional interface method add. Okay, so I'm just removing this one. Okay, now you don't find any compile time error here. So I'm just passing these two functional interfaces, these two lambda expressions to another method like this. Okay, so I'm just, it is as we discussed, I'm sending a block of code as an argument to another method. Okay, so this is how I'm sending this block of code to another method. Here I'm just calling the respective add method or foo method. You can the method name can be anything. So here we don't use any method name here. You just follow the method signature. We can have any method here. So we need not to write functional interfaces like this. We have some predefined, as part of Java 1.8 they have introduced some predefined functional interfaces which are having only one method. We can also go with them. So let's go back to our PPT. So as we discussed, these are some of the examples of lambda expressions. The first lambda expression is taking two arguments and just returning the sum of the two numbers, takes two integers and returns that sum. So this we need not to declare the types of the variables. So the compiler is smart enough to identify the types. So here I'm just passing x and y. I'm just returning the difference. Okay, and this functional interface is having no arguments and just returning 42. It always returns 42. And the next lambda expression is taking string as an argument. I'm just printing in the console. The next lambda expression takes number and returns the result of doubling it. Okay, like this we can have a number of lambda expressions. So what is a functional interface? As we discussed, a functional interface is like nothing but an interface which is having only one method. Okay, functional interface is defined as any interface that has exactly one explicitly declared abstract methods. Functional interface is one whose type can be used for a method parameter when a lambda is to be supplied as an actual argument. Okay, and let me show you another example of lambda expression. So if you look at this example, so I'm trying to create a thread, okay, by implementing the runnable interface. This is how I create we usually create a thread by implementing the runnable interface. So we need to implement this run method, right? So this runnable is an interface which is having only one method, so we can treat this interface as a functional interface. Okay, So this is the traditional way of coding. So as for from Java 1.8, we can also create a thread by just passing a lambda expression. Okay, this run method is not taking any arguments. Okay, so just simple braces, arrow mark, and then the body of the implement um, lambda expression. Okay, so if we run this method, both should display the okay, there is no difference, both are same. So our next topic is streams. So one of the important feature of Java 1.8, streams represents a sequence of elements from a collection. Okay, uh, it's not a stream is an abstraction, it's not a data structure, it cannot hold elements like collection, list, set or map. Okay, and where you can store elements. So it just stream does not hold any data, it just represents a sequence of elements from a source. Okay, and the stream represents a pipeline through which the data will flow and the functions to operate on the data. So we can create streams like by calling the stream method from a collection classes. So stream returns a sequential stream considering collection as its source, and parallel stream method returns a parallel stream where it will take advantage of multi-core processing considering collection as its source. And these are the some of the Java 8 streams methods. So filter, which will filter elements from the streams. Okay, and map transforms the elements from one form to another form. Okay, and reduce, so it performs a reduction of the stream to a single element. For example, if you want to sum all the integer values in the stream, okay, we can use this function. So collect is the way to get out of the stream, it's a terminal operation. Okay, stream solve and obtain a concrete collection of values. So we'll see some examples. So if you look at this example, so here I have numbers from 1 to 10. Okay, it returns a list of integers. So I want to double only the even numbers and collect those even numbers into a separate list. So usually in a traditional way, we'll take all the we'll loop, we'll iterate through the list and we'll take the even numbers and we'll double it, and then we collect all these values into a separate list. Okay, so if you use the streams, it will be very easy. So from numbers, I'm just calling the stream method, so it will give the stream object. So in this stream object, I'm just calling the filter. So I'm just first initially I'm collecting all the even numbers. Okay, I'm collecting even numbers from this filter, so it will filter only the even numbers into a separate stream. So on top of it, I'm applying this map method, so it will transform each element, it will take each element and double it. Okay, and then the resulting list I'm collecting into a separate list using collectors.toList. Okay, this is a terminal operation. Until, so usually streams are lazy in nature, so until it finds the terminal operation, the previous all operations are lazy, it won't execute immediately. Okay, so if you run this example, okay, it will just double all the even numbers. Let us see a couple of other examples. So if you look at this example, I have a list of integers. So in this list of integers, my requirement is I'm just filtering the elements which are starting with C. Okay, and then I'm converting them into uppercase, and then sorting and displaying in the console. Okay, for these operations I'm creating a stream. Okay, from this stream I'm just filtering all the values which are starting with C. Okay, and then I'm applying some map function which will transform the data into uppercase. So if you see this code, so this is called a method reference, as we discussed in our initial slides. So we have a method slide, we have a method reference. Okay, so this is called a lambda expression. This lambda expression we can also write using method using method reference. So this method is part of string class, right? So I'm just the class name and double colon operator and the method name. Okay, so instead of having lambda expressions, we can also write method reference. So I'm just replacing this method reference with the lambda expression. Okay, so I can also the same thing I can also achieve with lambda method reference. Okay, this is also producing the same output. Okay, and then on top of this result I'm applying the sorted function, so which will sort the values. Okay, and I'm passing this each value to a this lambda expression which will print in the console. So let me run this program. Yeah, we will see the output like this. Okay, we look at other this next example. So in this example I have a stream of elements. Okay, I can also create a stream object like this. Okay, you can also create from a list, or you can directly create a stream objects like this. So I have a stream. I'm filtering only the values. I'm applying just filter method. I'm just printing each value in the console and just returning true. That means it will print all the values. So if I run this example, let us see what is the output. See, it is not producing any output because the streams are should be terminated with some terminal operation. So here you are filtering but not doing any terminal operation. You are not printing, or you are not collecting those resulting elements into a list, or you are not printing into a console. So it won't execute this filter method until and unless it finds the terminal operation. Okay, so the next example is this one. So I have a list of person objects. Okay, from this list I am creating a stream and filtering the persons whose name starts with P. Okay, and then I am collecting the resulting elements into a separate list. Okay, I am just printing this one. Okay, so if I run this example, so we will see the persons. Okay, the persons whose name starts with P. Okay, like this we can filter and apply these transformations as part of streams. So this is our last example. So here also I have a list of person objects. So from this person list I am creating a stream. Okay, so here what I am doing is just collecting all these elements into a separate list by passing some group. Here I can apply some group by operations on top of these person elements. So I can group by using name or I can group by using age. See here in this example, I'm applying some group by operation using age. So it will collect all the persons who are having the same age. Okay, so it will display the. So let me run this program so that you can understand easily. See, so for each age it will group all the elements as part of this age. Like this we can also apply some group by operations. Even if you want to collect these elements into a set, so I can also collect after applying this group by operation, I can also collect the resulting elements into a separate set. So it will eliminate duplicate person names. So let me show you, run this example. See, so if we have the same name, so it will automatically it eliminated the duplicate values. So like this we have a number of operations as part of streams. So like this filter, to array, all, match, collect, these are terminal operations. Distinct and find first. Okay, find any, find first. We have map to double, map to int, map to long. So we have a number of transformations. We can apply these transformations as part of this collection of objects. So try out some examples. Okay, these are all the Java 8 features, and we have one more important feature is date and time API. They have introduced new date classes as part of 1.8. So I will discuss them in our next videos. Okay, this is all regarding our Java 8 features. So thank you all, thank you for seeing this video. If you like it, please click on the like button. Thank you.